Today we will see CMOS inverter and we will study how to calculate and verify critical voltage levels and short circuit current of CMOS inverter for given specification by using multisim. Here are specifications in which VDD is equal to 3.3 volt, Kn is equal to 200 microampere per volt square, Kp is equal to 80 microampere per volt square, VTP is equal to minus 0.7 volt and VTN is equal to zero point 0.6 volt. Before going ahead, you should know what is an inverter. Inverter is a device which converts low input into high output and high input into low output. So here is the circuit diagram of CMOS inverter in which this is a PMOS and this is NMOS and drains of both transistors are connected together. Here is the one VDD is connected. Here we are giving the input and from here we are taking output, and at this point we will calculate short circuit current. So let's go ahead and see how to calculate critical voltages. So here VOH is equal to VDD is equal to 3.3 volt, VOL is equal to 0 volt, and for calculating VIL we will use this formula. VIL is equal to VTP plus Vout plus KR into VTN minus VDD divided by 1 plus KR. We can calculate KR by using formula Kn by Kp, which will give us a value 2.5. So if we substitute all the values, we will get equation VIL is equal to minus 0.71 plus 0.57 Vout. Let us consider it as the equation number 1. So when we give input as a VIL, the NMOS will be in saturation mode and PMOS will be in linear mode, and the IDN is equal to IDP. So these are the current equation. For IDN we will write the current equation in saturation mode, and for IDP we will write the current equation in linear mode. If we put equation 1 in above equation, we will get equation as 0.66 Vout square minus 6.706 is equal to 0. If we solve this equation, we will get Vout at VIL is equal to 3.1875 volt. Now from equation 1, we will substitute Vout is equal to 3.1875 volt in equation number 1. We will get VIL is equal to 1.1026 volt. Now we will calculate VIH by using formula VIH is equal to VDD plus VTP plus KR into 2 Vout plus VTN divided by 1 plus KR. If we substitute all the values, we will get the equation VIH is equal to 1.43 Vout plus 1.17. Let us consider this equation as equation number 2. When input is equal to VIH, the NMOS will be in linear mode and PMOS will be in saturation. So here are the equations. IDN is equal to IDP. For NMOS, we will write equation in linear mode, and for PMOS, we will write current equation in saturation mode. If we put equation 2 in above equation, we will get equation as 2.61 Vout square plus 6.94 Vout minus 2.04 is equal to 0. And by solving above equation, we will get Vout at VIH is equal to 0.266 volt. From equation 2, if we substitute Vout is equal to 0.266 in equation number 2, we will get VIH is equal to 1.5503 volt. Now we will calculate threshold voltage. For calculating threshold voltage, the formula is PT VTH plus equal to VTN plus square root of 1 by KR into VDD plus VTP divided by 1 plus square root of 1 by KR. If we substitute all the values, we will get VTH is equal to 1.3742 volt. For calculating short circuit current, we will calculate ISC is equal to Kn by 2 into VTH minus VTN bracket square, and we will get ISC as 59 microampere. Now we will verify critical voltage levels using multi-sim. Here is the circuit diagram for CMOS inverter. This is the PMOS, this is the NMOS. You should arrange the circuit like this. Now we should set some parameters of transistors. First we will double click on PMOS and we will change some values. I have changed already. You should go to edit model and set the threshold voltage as a minus 0.7 and Kp transconductance parameter is 8 e raised to minus 0.005, which is 80 microampere per volt square, and just you have to click change component. I have changed already. Then OK. Now we will double click on NMOS and here we will go to edit model. We should set VT0 as 0.6 and Kp as 200 microampere. Now we will go to simulate analysis and simulation. Now go to DC sweep. Here you have to set source as a V. Go to output. You will get here variables ISC and V out. Then save it and run. To show cursor, go to cursor and click on show cursors. Here we will get cursors 2. Here cursor number 1, cursor number 2. So now we will check values here. Here we have got VIL is equal to 1.1026. We will check V out at VIL. Now we have to move cursor to 1.1026. We will move cursor to here x2 is varying 1.01. Now see 1.10, sorry, we will move it to 1.10, and what we will get, we will get output as a 3.066. Here we are getting 3.18, which is approximately equal to 3.066. So we are right, our calculations are right. Now we will check V out at VIH. Now we should move cursor to 1.5503. 1.55. Here we are getting 268.8964 millivolt, and we are getting here 0.266 volt, which is approximately verify short circuit current. Short circuit current is the current at threshold voltage. So we should move cursor to threshold voltage, which is 1.3742 volt. So here is the 1.3706, at which we are getting current as 59.3035 microampere, and by calculation we are getting it as 59 microampere. So our all results are verified. So here is the tip for you, how to take this axis at right side. For getting it, you should go to graph, and in graph go to properties, then go to traces, select trace ID. I is equal to ISC, trace ID 1. Here Y vertical axis, right axis you should select, then go to right axis, select range 0 to 7 into e raised to minus 005, and you should enable this axis, then apply and OK. You will get this axis. Thank you for watching.